Algebra 2, Lesson 35, Angles and Polygons, Inscribed Quadrilaterals, and Fractional Exponents. So, we're not going to touch too much on inscribed quadrilaterals because they can kind of follow the exterior and interior angle rules. So the first thing we're going to go over is practice A. Why is my focus always messed up? Alright, here we go. Practice A. We got to find the sum of the interior angles in a 14-gon. Just a polygon with 14 sides. And then to find the sum of the interior angles, we have to remember our equation, which is number of sides minus 2 times 180. So, number of sides we're just going to fill in as 14. 14 minus 2 is 12. So all we have to do is take 12 times 180. So if we take 12 times 180, we can do some quick multiplication. 10 times 180 gives us 1800. 2 times 180 gives us 360. Add those together and we get 2160 degrees. 2160 degrees. So that one's not too hard. We just have to remember this equation. Number of sides minus 2 times 180. And that is for interior angles only. Interior angles only. Now, practice B is kind of a trick question. They want us to find the sum of the exterior angles in a 14-gon. Now, the reason why this is a trick question is because the sum of the exterior angles in any convex polygon, meaning it doesn't have a cave in it or it's not concave, is going to be 360. So, the answer to B is just 360. And you can just remember that because all exterior angles always add up to 360. It's like if you were to spin in a circle, you would spin 360 degrees. So those are pretty easy. Now let's go on to fractional exponents, which can be a bit of a pain. Starting with C, we have to simplify 64 to the exponent of 1/2, negative 1/2. First thing we're going to do is we're going to make this a positive exponent. So we'll move it to the denominator, 1 over 64, 64, to the positive 1/2. And then remember that fractional exponents are kind of like radicals. Well, they're exactly like radicals. So this can be written as 1 over the square root of 64. Using factoring, we know that that's going to be 8 times 8. That gives us a pair. It satisfies the 2. So the answer is just going to be 1 over 8. Now let's move on to D. It gets a little trickier. They don't throw a negative exponent at us, but then they give us a weird root. It's actually a cube root. So what we do here is remember the denominator is going to be the number that ends up inside our radical. And then the numerator is just going to be the exponent of whatever's inside of it. Now, we could do this 64 squared. We could multiply 64 times 64 and then get a huge number and then have to factor a huge number, or we could just break up the radical and write it as the cubed root of 64 times 64. It's kind of like we already started our factor tree. From here, we just have to factor this and then look for 3's. We know this is going to be 8 times 8, and this is going to be 8 times 8, and I don't have to get to prime numbers. I see I've got 3 8's. I can pull those out and make one whole number 8. Now, the last thing is to factor this 8. It becomes 4 and 2. 4 becomes 2 and 2. I've got 3 2's. So those will come out. And then I've just got 8 times 2. 8 times 2 gives me 16. The final answer is 16. So that one can get a little bit tricky, but if you set up the problem right and you remember that you don't have to multiply these big numbers because you're just going to factor them anyway, it's really easy to find and you don't even need a calculator to do it. Last one. We have negative 125 to the negative 2/3 exponent. Now, the cool thing about this negative is it's not enclosed in parentheses, so we don't have to worry about it. We can just put our finger over it or work the problem without the negative and then make sure we apply it at the very end. So first, we'll turn this into a positive fraction. Make it negative 1 over 125 to the positive 2/3. And then we're going to do the same thing we did in the last problem. This denominator goes into the radical, so now we've got 1 over the cubed root of 125 squared. That's going to get rewritten to 1 over the cubed root of 125 times 125. From here, we'll go ahead and start factoring. 5 times 25 will equal 125. Still don't have any 3's yet. And then 25 will factor into 5 times 5. So then I've got one group of 3 here, which gives me a whole number 5, and then another group of 3 here, which gives me another whole number 5. So 5 times 5 gives me 25. And then I can't forget about my negative. All right, and then it's also in the denominator. So the final answer is just going to be 1 over 25 negative. So negative 1 over 25.